Okay, welcome. Been a while since I was here. I don't have a second screen, so I'm just kind of guessing at what I look like. Um, yeah, I think everything's fine. I'm just going to go through a little bit of, how I basically make scripts with a single node editor in Grasshopper and how I use ChatGPT to do pretty much anything that comes to my mind. So what I'll do here is I'll just start over. I will save and I will file, save document as. Oh, these were tessellations. Actually, I think that was the tessellations. Let's just build a folder of, I don't know. Let's just call it math and physics, and get started with that. And we'll just do a nice simple intro 001. That's it, Grasshopper script. We take all this stuff and get rid of it. And all you want to do is go up to Math tab and pull down a node editor, put it in Python, and you're ready to start scripting. So get rid of that and get ready to go. That's it. And we'll call it whatever we decide to call it. So this is intro, and we'll just do an intro. And there it is. So we're going to need some inputs and outputs, but we'll make it parametric as we go, and let's see what it dreams up for Rhino and Grasshopper. So let's go back over to here, and let's say, please create a Python script for the new node editor in Grasshopper for Rhino 3D that generates points and curves, curve outputs for understanding complex trigonometry and physics. Visually in CAD 3D models in the Rhino 8 environment. So how you end up is you don't have a plan. Like you have a plan loosely of what you want to do, and I've got some GPT-01 still remaining, so it's using its thinking and reasoning. And I might just want to check that this is recording nicely, but basically it's going to output a script. And I'm just interested in math and physics today. I could pick any subject anywhere. All this jargon comes out, blah, blah, blah. All these wonderful things for inputs. It's going to generate some points and curves in a very simple way. And it's just going to be something really simple to start. So we're going to take that script, copy it, and we're going to paste it. And we're going to run it. And we have a bug already, which is not really a bug. It's the fact that our inputs are not set up. So steps is not set up. So we need to definitely go in and find out what our inputs are. And here they are. Inputs need to be amplitude as a float. So we will go in here and put amplitude in as a float. Oops. Amplitude in as a float. And we will cancel that. We will put in frequency as a float. And we will put in steps as a integer. Steps as an integer. And I think we should be good to go. We want output to be A and B, which is points and curves. That's it. We set this up so we can debug it. I think we're good to go. So we can close that. We can go here and just grab our debugging panel, and we can take a look at what points come out, and we can take a look at what curves come out. So that's nice. Obviously we have a list of points, so we have a list, one curve. And there it is. So we're going to have to zoom extends all. And we definitely need to have an amplitude, so let's go negative 3.00 to 3.00. We'll use that as an amplitude, and we will use that as a, and we'll just bring this around here, whatever we want. And steps, we'll probably want to do quite a few, but let's start with just 12. And it should be fun to see what's happening. There it is. And there's our little bit of geometry, math, and you can see that we have a lot of steps that we can put in here for finesse. We can take our amplification, we can make it swirl, we can turn it backwards, we can turn it forwards. It's a nice little script to make a helix. That's it, and we can change our amplification if we want to change that as well from -3 to 3. So we'll go 3, and we'll just crank this up to by 3. And there you go. Nice little helix with 100 points, and you can do whatever you want with it. So that's it. Now, what you'll end up doing is you'll take that, and you probably will want to copy that and take this curve and put it disabled. And now you want to make it more complex. So you're going to go in here and you'll grab all your script, Control A, and get rid of it and reset it and see what new variables come into play. So go back and say great. Now demonstrate much more complex mathematics and physics principles to the level of a PhD student. And there you go. More complex, more detailed, and more parametric. Controllable. Alright, let's see what happens. And hammer out that code. That's it. And now we'll just have to add new variables. We'll get new geometries, and we can just kind of loosely. And you can do any subject imaginable. So if you're one that, like me, that kind of wanders into the library and kicks the shelves and sees what's interesting in the world, this is basically how I do it. There's nothing tricky about the Wickerson way. If you want all this work done for you, take a look at wickersonstudios.com, take a look at the Patreon, and I have thousands and thousands of files, and in this last year, more recently, these single node editors to make stuff more complex. So let's see what it produced for us, blah, blah, blah. You can see some of the formulas it's throwing in, yada, 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 with constants. Here we go. We're going to have a, I think what we're going to do is we're going to have to go in here. Inputs are going to be blah, blah, blah. Dampening ratio, natural frequency, all these things have to go in. We still have steps. We're going to want to, and this is where it gets a little tricky, we're going to want to take inputs, an example, typical inputs. So we want this at 0.1. So we're going to go in here and we're going to change that to 0.1. A ratio, make sure you don't have that little space at the end. Float, and we're going to take this down to 0.100, and that's going to be the dampening, and we'll leave it at what it suggests, 0.1. Let's take a look at the next one. This one's at 2.0. This is natural frequency, so we're going to take that. Let's make sure we get it exactly. Natural frequency, and the frequency here, we're going to go to natural frequency, and we're going to keep it as a float, and we're going to set that to, I think it was, yeah, it was 2.0, so we could just leave it as 2. All right, that's good. And then let's just get ready for this all the way through the steps. How many were there in between? There were 1, 2, 3, 4, 5 in between. So 1, 2, 3, 4, 5. And those things are going to be amplitude. They're going to be all floats, all between 1 and 2, and then up to 10. So this one's going to be, and we just want to not get that space there. Grab this and put it in here. And we're going to have that as a float. And we're going to go into forcing frequency right here. We're going to copy that. We're going to go in and put that in. Forcing frequency as a float. And this is for people who want to data visualize with Rhino and 3D models, mathematics and physics. Say you just need a little help, and this is kind of how you're curious, like myself. It's not for everybody. but it is the Wickerson way. And like I said, wickersonstudios.com and Patreon, tons of these. Initial velocity, we're going to start it at not a negative, we're going to start it as a positive. And then the last one is a time span, 10 seconds. We're going to let this go up. Yeah, we're going to see what it does in 10 seconds. We're going to go here for time span, and this one's going to go up to 10 seconds. So for our conditions that it was suggesting were 2, 1, 1.5, 0, 1, and 10. 2, 1, 1.5, 0, 1, and 10. I'll probably screw that up. 2. Yeah, we could just set that to 2 and bring it back down to 1. There we go. And we could take this one and go to 1.5. And then I think initial velocity was 0, which is cool. Even though we could have it at different initial velocities, so we could have it speeding up, but we're going to put it at 0, and we want a time span of 10 seconds. But we're going to do 12.00 seconds, and that's it. We're going to clear this up. We're going to hope our script runs, and we're going to go back in here, and we're going to copy that code. And you can read all you want about this. We're going to have an output of time series points, a phase portrait. I don't know what the phase portrait is going to be. Probably a curve, and a curve 3D. So we're going to go on here, and we're just going to double check with a geo just to see. Actually, we could just do a panel to see what comes out, because I'm not really sure what's going to come out of there. So we're just going to pop on and see what comes out of B if it works, and we'll see if there's any debugging. And we'll go in and we'll grab our script, copy it, and we will paste it in here, and we will run it, and hopefully it works. And we get a bug, and the bug is blah blah blah. FO is not defined, so we have more variables. Time phase, blah blah blah. Da, 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 da. Define. Let's da, 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 da. So it wants FO is not defined. So we might have to should be something here. It's FO. There's the curious thing there. Let's just see where that comes up. FO times. I guess we could just put it in there. Yeah, prime FOC. Well, we also can just grab this and hit data collection, and we can go back in and we could just type it in as a bug, and we don't have to really think too hard about that. It might resolve it without me having to chase it or hard code it in. I don't know. Let's see what happens. We are dealing on a PhD level here, so we've got to be careful. You can read all this if you liked. Since ID functions are recognized, and if this happened, blah blah blah. Names like the code, Python cannot handle them as expected. All right. So what is it going to do differently? Here we go. It's going to pump in all these variables. It's going to still ask us for these forced amplitude, initial velocity, and all this, and it's going to solve all those problems right there for us. So instead of me having to pick through it and find out what exactly they are and assigning it, looks like we can just grab our code, head back in, select A, cut and paste the new script, and there we go. We're done. There we go. Now that is pretty cool. All right, so these are, I believe, points. So I can take points, and I can grab here, and I have my output, and there it is. And I could also interpolate that, and of course the curve is here, and I also want to take my other curve and have this one. These points, why would that, oh, what am I talking about? Can't just go into a curve, have to interpolate. Sometimes you have to know a couple of things. Interpolate those points. There we go. And there you go. So this is pretty interesting. A little more fancy footwork. These points initially, these points, and this curve comes from it. So now you've got a visualization of something a little more complex. Also, you have something that's really kind of interesting that you can think about playing with. So if we take the dampening, that's going to change what happens all the way from 0 to dampening it to control it, kind of get control of that curve. Now think of this. Oh my goodness, the natural frequency is just wild on this curve. Fantastic. And then I've got my forced amplitude to have a lot of control. This is fantastic. Just playing with functions in 3D space and then forcing frequency. Oh my goodness. Just think of that as a toolpath for a robotic toolpath, or this is a profile curve on a revolution on a piece of pottery or something like that. Initial displacement I can control, and then I can also have my initial velocity working at different speeds. This is a fantastic model, and that's why the Wickerson way is just friggin' amazing, because you can go into it with kind of concepts of what you want to do, and this one's just extending through time, so it's just throwing through a long seconds. But if we stay to the first 10 seconds, we can kind of see what this is doing. So I would think of this as a generation of toolpaths, robotic toolpaths for applications, and then my steps are how many steps I want in there, so I'll just leave it at 100. Pretty fantastic. So from an introduction of just math and physics, we've actually got this, and I'm going to hit save. This file I'll put up online. I'll play it with this video, and I also will throw in, just for those that wonder how I went about doing it, I'm going to tilde blah blah blah, and then I'm going to go into my, just for your sake, I'm going to go in and share that link, copy my link, and then I'm going to put my link in here for my GPT link, which is right here, and there you go. That's your Chat GPT link. That'll get you everything I did, break it down, and you're able to see what's happened. Pretty fantastic. So that's it. I'll take a little screenshot, and that's all she wrote.